Hey guys, welcome back to day 15 of doing one quant finance standard question every day. And today we have a relatively easier question compared to like the days before. And today our question is, let x not be 0 and let x1 through x10 satisfy that the absolute value of xi minus xi minus 1 equals to 1 for 1 smaller than I smaller than 10. And x sub 10 is equals to 4. So how many sequences are satisfying these conditions? So this question is not that hard if you know how to think about it. But like usual, I want you guys to take a moment and think about this question, and I'm going to explain the solution in just a little bit. So the correct answer to this problem is 120. So there are 120 different ways or 120 different sequences that satisfy this condition. And for a problem like this that has like a lot of different symbols and variables, I usually like to start approaching this problem by having one example of what this process is going to look like. So we know we always start with s not equals to 0, and we have 10 numbers following that. We have 10 numbers following that, so x2, x1, x2, x3, all the way up to x10. And what this condition tells us is that the difference between any two consecutive variables is 1. It doesn't matter if it's plus 1 or negative 1, but the difference is going to be 1. So, for example, x1 could be either 1 or positive or negative 1. And x2, you can build it on top of the 1 or build on top of negative 1, doesn't matter. So, one such sequence might just be 0, 1, 2, maybe you go down 1 is going to be 1. So after these 10 variables here, you want to make sure that you always end with x10 of 4. So that's what this question is really is about. So you want to have 10 variables where at the end you get a 4. So that's all we need to know. Okay, let's think about this, right? So if each variable can just be the previous one plus or minus 1. Maybe you can just write that number as plus 1 or negative 1, plus 1 or negative 1, plus 1 or negative 1. And each of the 10 variables are equally likely. They all can have plus or negative 1. But eventually you want to make sure your last variable is 4. So this turns to a problem where instead of asking how many sequences there are satisfying these conditions, it's basically asking how many different ways you can arrange 10 plus 1 and negative 1s to have a total sum of 4, because you always start with 0. And yeah, so whatever you add on from x1 to xn, you have to have a total sum of 4. And how many ways can we do that? Well, okay, let's say we have x number of minus 1s, and then we know if our final sum is 4, then we have to have 4 more plus 1s than minus 1s. So our number of plus 1s would be x plus 4, and this have to be equal to 10, because we only have 10 variables, x1 through x10, there are exactly 10 variables. So I want to make sure to add it to 10. So solving this simple single variable equation gives us x equals to 3. So x plus 4 will be 7. What this means is we have to have 7 plus 1s and exactly 3 minus 1s. So how many ways can we arrange that? Well, from the basic combination, we know the way how many different ways can we choose 7 out of 10. That's going to give our answer. So that's 10 choose 7, which is 10 factorial over 7 factorial times 3 factorial, which happens to be 10 times 9 times 8 over 3 times 2 times 1. Cancel these out. Gives us 10 times 12, which is 120. And that's how we find our solution. It's relatively easy if you know how to do n choose k. But let me just quickly explain why we do n choose k and how we derive n choose k. So the notation n choose k, you might have seen in your statistics textbook before. The idea behind interest K is really simple. It's basically trying to answer the question, how many ways can we choose K items from a total of N items. And here's the important part. Assuming the order doesn't matter. So what do I mean by that, huh? Let me explain this concept with a more concrete example. Let's say we have 5 numbers, just 1, 2, 3, 4, and 5. And you want to choose 3 numbers out of them. So in this case, our N would just be 5 because we have 5 different total numbers I want to put into 3 different boxes. So N equals 5, K equals to 3, and that's pretty intuitive. And let's think about this. Okay, let's just look at the first box. How many options do we have? How many numbers can we put in the first box? Well, we have all 5 numbers with us because we haven't put in anything yet. So the first box has 5 different options. But now let's go to the second box. Okay, we already put in 1 number into the first box. So the second box only has 4 options left. And then the third box, we're already putting 2 numbers into the first and second box, and therefore the third box only has 3 options left. So the total number of possible arrangement, which would be 5 times 4 times 3, which is equivalent to 5 factorial over 2 factorial. And if you write it in terms of N and K, and it's going to be N factorial over N minus K factorial. So this is the total number of possible ways that can range 5. Choose 3 numbers out of 5. But here's the kick. We said assuming the order doesn't matter. What I mean by that? Okay, let's do a few rounds of putting the numbers in. Maybe we can have 1, 2, 3. Maybe we can have 3, 2, 1. Maybe we have 2, 3, 1. We know it's the same 3 numbers, but if you just keep doing these are valid possible outcomes. And these are counted in our N factorial over N minus K factorial. But if we say the order doesn't matter, we got to view all of these as one possibility. Since order doesn't matter, we're just looking at what we actually have. One possible solution. So basically, we're overcounting the possibilities by not ignoring the order. So how many different ways can we arrange 3 numbers into 3 different boxes? The answer is obvious. It's 3 factorial. So to avoid this overcounting problem, or to cancel out this overcounting, in fact, we always divide it by N, did I say N factorial? Divided by K factorial at the very end. And that's how we get our formula. N choose K is always equal to N factorial over N minus K factorial times K factorial. And this is called combination. Well, there might be some certain cases where we don't want to ignore the different ordering, or when order actually matters. If that's the case, it's called permutations. We just wouldn't divide it by the K factorial. We'll just use this. That's called permutations. So yeah. So that concludes our day 15 of doing 1 quant finance interview question every day, and I hope the video is helpful for you. So if you liked it, please drop a follow and come back tomorrow for day 16. Thank you.